Headwaters is brought to you by the Glacier National Park Conservancy.
They kind of look a little bit like nicotine patches for trees. Right. Or like sugar packets, I guess would be a nicer thing to say.
Wait, what is going on here?
Well, recently, Andrew and I tagged along on a hike to Scenic Point with the veg crew, the park's plant people. And shortly after reaching the top, I was handed a Bosstitch heavy-duty stapler and a small white packet.
The nicotine patch, a.k.a. sugar packet.
Yes, which turns out it's actually a packet of a synthetic pheromone called verbenone, which is a defense against one of the West's most infamous forest pests, mountain pine beetles.
Ah.
We don't want them killing our whitebark pine trees, so we were sent out there to staple verbenone packets, these synthetic pheromones, right onto the trees themselves. Here's Reveg crew member Annie Gustafson walking me through it.
Okay, you're going to take the packet of verbenone and you're just going to put 2 staples up top and then 1 down below.
Okay. How hard do you have to swing this thing to get it to?
5 miles an hour.
That's impossible to judge my hand. No, it even says staple here.
Here we go.
Don't hype it up.
Nice. Okay, now here's the tough one. Bottom stable.
Is that good enough?
Yeah.
So what grade would you give him?
You got a B+.
Easier said than done.
Oh, no.
That was a misfire. There was no staple, right?
That one's a D.
So how do these packets keep the beetles away?
Well, I'll let Rebecca Lawrence explain. She runs the Reveg program around here and is an excellent verbenone stapler, I might add.
Well, it tells the beetles that other beetles have occupied that tree. There's no vacancies, so that they'll go somewhere else to another tree.
Very clever. So they're using the beetles' own language against them.
Exactly. And the goal is to place these no vacancy signs at the outer edges of important high elevation forests, a sort of great wall of sugar packets that keeps the beetles out.
Okay, I like it. And did it work?
It seemed like it. I mean, we never saw any beetles when we were up there, but we did see evidence of a different threat. Here's Rebecca again.
This is active rust, where the cankers are opening up and releasing the spores, and it's a bright orange that looks like your Kraft mac and cheese powder.
Throughout the Rocky Mountains, whitebark pine trees are dying, and here in Glacier, beetles are far from the largest problem.
Basically, the bark starts to just erupt open, and then the spores pop out.
These trees are being protected from beetles because, up until now at least, they've been doing great at surviving an entirely different disease, white pine blister rust, which has already killed over half of the whitebark pine trees in the park. These big, mature, cone-bearing trees have been showing resistance to the disease for decades, and the crew has been visiting and verbenoning them since 2007. But today, the crew noticed blister rust on several, turning what should have been an annual wellness check into a sort of inevitable goodbye.
It's sad to see, I don't like to see them dying off, but it's not surprising. Even if just a fraction of them survive, hopefully we can maintain a little foothold up here.
My name is Peri, and this is Season 2 of Headwaters. We're calling this season Whitebark Pine. But this story is also about so much more than a tree. It's about the purpose of national parks and our relationship with the places we love.
I'm Andrew.
I'm Michael.
Hopefully you've already listened to chapters 1 and 2, but if you haven't, those are a great place to start.
This is chapter 3 of a 5-part season.
So far, we've introduced you to whitebark pine, learned about its cultural significance, and heard about the intricate web of life that's connected to this tree. Now, we meet the things trying to kill it. So, Michael, hearing about your field day with Rebecca makes me think of this quote by Aldo Leopold, the famous conservationist. He said, One of the penalties of an ecological education is that one lives alone in a world of wounds. I'm realizing that a lot of this whitebark pine story is invisible, something that a layperson wouldn't even notice, but that's a catastrophe to an ecologist and the worlds they study.
Definitely. I mean, I would have never noticed the blister rust on those trees if Rebecca hadn't pointed it out.
And I'm no ecologist, but as I learn more about whitebark pine, I think I'm starting to get a glimpse of what it feels like to see these hidden tragedies unfolding. In Chapter 1, I asked hikers on the Pegan Pass Trail if they knew what whitebark pine were, and most of them didn't, even though we were standing right next to a ghost forest of dead whitebark. I felt like I was seeing a world they weren't. Professor Diana Six is an ecologist at the University of Montana who studies the threats facing whitebark pine. And today, I'm going to hike back up the Pegan Pass Trail with her. We're going to find a big, healthy whitebark pine and core it to look at the rings, see what it's been through, and ask why it survived.
So my name is Diana Six, and I'm a professor of forest entomology and pathology. I really did start my love of nature and insects as a little kid. I was camping when I was in diapers. I've been out in the forest, in the desert, all my life.
So I'm just envisioning 5-year-old Diana. Did you bring all these bugs into the house? What did your parents think about this?
Yeah, everything came in the house. I collected the most famous thing that put some controls on me was I brought home all these little wigglers and put them in my aquarium. And of course they were mosquitoes. And when they hatched, I was in big trouble. And after that, I wasn't allowed to bring live stuff in the house anymore. I begged for a microscope for years and I always got these stupid dolls. I'm old enough that in those days, women were not encouraged in science. We weren't even allowed to be in the science club. So I never, ever considered that it could have been a career, that I could have gone on to do science or bugs for sure.
You might think of a forest entomologist and pathologist as a bit of a nerd, but Diana is very cool. She has all this amazing insect-themed silver jewelry and listens to heavy symphonic metal, works all over the world, and is very far from the stereotype I imagined. As we hiked up the trail, I asked her what whitebark pine is up against.
So the three main threats really to whitebark are climate change, blister rust, and mountain pine beetle. And the fact that we have those three, and they're all big, makes this a particularly wicked problem. And wicked problems are those kinds that are not only difficult to solve, but they have multiple facets. And so one aspect could be really difficult to fix. But if you come up with a solution for that, you're still going to lose what you're focused on because you still have these other threats that have to be dealt with.
The other thing that makes this a wicked problem is that these threats interact. For example, climate change is enabling beetles to attack whitebark pine.
Mountain pine beetles are native, which surprises some people because they've killed so many trees they act like some invasive, but they're native.
In a way, mountain pine beetles are new to whitebark. Beetle larvae are killed by really cold temperatures, which used to be common in the high elevation areas where these trees live.
But with climate change, it's allowed things to warm up. The beetles can move up the mountain now. And now it's warm enough on the tops of the mountains all of the time that the beetles can persist there pretty much as residents now. And this is a big problem because whitebark, having been protected for so many years, has never really had to evolve strong defenses against this insect. And so when this insect shows up, it doesn't have a really good way of fighting back. So if you go to lower elevation trees, they've got all this resin they produce, they drown the beetles, they produce all these toxic chemicals. Whitebark doesn't do that. It's a sitting duck. And the beetles just bore in, they don't get drowned, Doesn't take very many beetles to kill the trees. And it's just a disaster because, well, so many of the trees are so susceptible. And we've seen millions of acres now killed by the beetles just in the last 10 years.
So I feel like you could definitely see pine beetles as the villain in this story, or the bad guy. Do you see it that way, or?
No, ultimately they're just doing what they do, right? They're native. They have in the past always been actually good guys because they regenerate forests. They're a natural disturbance agent, just like fire. And so the forests that have evolved with them really need them periodically to kind of stay vigorous and healthy. Now that we're seeing these really big outbreaks, this is outside their norm. And the root cause of that is not them, it's us. And with a changing climate, these beetles are responding to warmer temperatures, weaker trees by blowing up.
Mountain pine beetles have killed a ton of whitebark pines, especially where they grow in mostly uninterrupted stands of just whitebark, like in the Yellowstone area and in parts of Idaho. And they kill them really dramatically and quickly. Whole hillsides of whitebark will turn red and then die within a couple years. But here in Glacier, blister rust is an even more insidious threat.
This is a really serious situation because, of course, it's an invasive disease. It is not meant to be here. The tree really has very little resistance. This is a tough one.
Blister rust is a fungus, but not like mushrooms you might picture on the forest floor. Blister rust grows inside the living tissue of other organisms, and its spores are spread through the air, entering through pores on the tree's needles.
So when a tree gets blister rust, the infection begins in the needles and then will move down through the branches. And at that point, it's really not a big deal. It might kill a branch or something. But once it gets into the main stem of the tree, that's the problem, because there it will begin to move horizontally around the tree, which causes something we call girdling. And it will kill this phloem layer that conducts the nutrients for the tree. And once it does that all the way around the tree, everything above that point on the tree dies. And so even if like the bottom half of the tree is still alive, it's not going to produce cones anymore. So it becomes what we call ecologically dead. It's still alive, but it's not reproducing, it's not passing its genes on, and it's not helping the population survive. And eventually that part of the tree will die too.
Blister rust spores spread under cool, damp conditions, so Glacier's climate is perfect for it. And it's killed between 50 and 90% of the whitebark in the park.
And there's been a lot of work on it, and luckily people are finding resistance.
That is, that a small percentage of whitebark pine are naturally resistant to blister rust.
They're having success at developing trees that can be planted out that have more resistance. So that's promising, but it's a real uphill battle.
In addition to pine beetles and blister rust, the third threat whitebark pine are facing is climate change, which is a threat all on its own, but it also makes the other two worse.
I personally think climate change is the very biggest threat, because that's really the hardest to deal with, right? If we could find enough resistance to blister rust, if we can find enough for the beetles, if they have that evolutionary adaptive capacity, they could probably persist. But then you throw climate change in, makes the beetles worse. It can make blister rust worse in some places if it increases conditions for infection. But it is very much going to affect the range of where this tree can live. And so if you have a greatly changed climate and it's too warm, it's too dry, even if you had all resistant trees, they can't live under those conditions. And it kind of seems like a no-brainer, but the forests that you have in a certain place are what they are because of the climate. So if you change the climate, you change the forest.
To set the stage, white pine blister rust is a fungus native to China, And it affects white pines, which is a term that describes whitebark pine and all of its closest relatives like western and eastern white pines, limber pine, etc. It arrived in North America around 1900, but it didn't cross the ocean on its own. It hitched a ride on American pine trees growing in Europe.
Why were American trees growing in Europe?
They were being grown as timber species in nurseries, tree nurseries, which were a new concept at the turn of the century. Many people began to fear that the once limitless forests of North America were being depleted, turned into homes, paper, railroad ties. People like Gifford Pinchot, who would go on to become the first director of the U.S. Forest Service, began to advocate for the idea of modern forestry.
What would make it modern forestry?
Well, really just forestry in general. It was kind of a revolutionary idea to treat forests like farms instead of like mines, replanting things instead of just harvesting them. So in the early 1900s, you could raise seedlings in an American nursery, but it was expensive. There just weren't that many in this country yet. It was a lot easier and cheaper to send them to Europe. So you could send a white pine seed to a German nursery, and they would raise it into a tree and ship it back across the ocean. But a lot of people were cautioning against that because of the threat of blister rust.
So someone saw this coming from miles away.
Miles and years, because in 1898, Dr. Carl A. Schenk, a German forester, predicted disaster for America's white pines if we imported nursery stock from Europe. And that warning went unheeded.
I'm actually kind of shocked that they knew about blister rust and somehow it made it here anyway.
Yeah, about 10 years later, by 1909, the U.S. had imported millions of eastern white pines that had already and unknowingly been infected with blister rust.
Well, hindsight is 20/20.
It is. Hindsight is 20/20, but they didn't need hindsight. This exact story was already unfolding on the other side of the country with a different tree. The American chestnut.
Do you want me to say hi or no hi?
You can say hi and then your name.
Okay.
So I enlisted some help from out east.
Hi, my name is Wendy Cass, and I'm the botanist at Shenandoah National Park in Virginia.
Wendy works at Shenandoah, a national park in the Blue Ridge Mountains of Appalachia, and I wanted to talk to her because Shenandoah was home to a lot of American chestnut trees.
About 35% of the park area was probably pure chestnuts. Pure chestnut forest. And then another 40% or so of the park probably had chestnuts mixed into the canopy. They talk about how the mountains look like they were capped with snow in the spring because of all the chestnuts flowering here. So they were just enormously abundant.
They covered a range from Georgia to Maine, and they were enormous.
Some of them had trunk diameters of 8 or 9 feet. That's diameter, not a circumference. And they would live for well over 100 years. So these were just amazing trees.
I grew up in the Midwest. I spent time in Appalachia as a kid. I couldn't remember ever encountering an American chestnut. Not that I really knew much about the trees around me, but the only thing my mind kept coming back to was, it was probably the one referenced in Nat King Cole's The Christmas Song.
Oh, sure. Chestnuts roasting on an open fire.
Yeah, I was like, that must be a reference to them.
Is it?
No, it was not.
It wasn't?
No, because that song was written in the 40s after American chestnut had disappeared from the forests. Those were not American chestnuts. Those were the same kind of European chestnuts you buy on the street today. They're much bigger. They look different.
Luckily, I got a hold of Susan Frankel.
My name is Susan Frankel.
She wrote the book on chestnuts.
And I'm the author of American Chestnut, The Life, Death, and Rebirth of a Perfect Tree.
White pine blister rust was not the first forest pathogen encountered in the U.S., and it wasn't the deadliest either. Our response to blister rust was informed directly by what we learned from another fungus, chestnut blight.
The blight that decimated chestnut trees is sort of the touchstone for anybody who works in forest pathology because it was such a devastating epidemic.
Like blister rust, chestnut blight was discovered in North America at the turn of the century in 1904.
A guy who worked at the New York Zoo noticed that some of the chestnuts in the zoo were dying. That was when people first became aware of the blight.
And just like blister rust, chestnut blight was invasive.
Well, where did the chestnut blight come from?
Well, it took a while, but scientists were able to determine that it was native to Asia.
This fungus had come from Asia and had probably arrived in the U.S. on Japanese and Chinese chestnuts that had been imported to the U.S. as sort of ornamental trees. but it doesn't kill the chestnut trees in China and Japan. They've sort of co-evolved with the fungus and are able to withstand it.
The blight's arrival to the New York Zoo was just the beginning.
You already had outbreaks that were taking place but unrecognized in Virginia, in Pennsylvania, in New Jersey.
It's not like there was a proverbial patient zero and everything stemmed from that. It was on all these different fronts across the nation at the time.
Exactly. There were, thousands of patient zeros.
From each of these initial hosts, the blight in the form of fungal spores spread incredibly quickly.
And it's spread by air, it's spread by water, it's spread by, squirrels' paws, birds' claws.
Once it infects a tree, it takes over.
It's a very, very lethal fungus. The trees died quickly. They would turn silvery, a kind of gray color as the bark fell off and the wood died. And people talked about, coming across stands of these gray ghosts or hearing the trees crash to the ground at night.
And contrasted with whitebark pine, a tree most folks have never heard of, American chestnuts were present in people's everyday lives. It was a cradle-to-grave tree, meaning it was used to make everything from cribs to caskets, pianos, railroad ties, telegraph poles.
Chestnuts were a source of the lumber from which people built their homes. The bark would shingle their houses.
They were an especially important resource for the people of southern Appalachia.
They would stuff their mattresses with chestnut leaves. They would brew the leaves into poultices to deal, as a remedy for colds. And the nuts were a really important source of both food and cash for them.
So when chestnuts started dying, people took notice.
When the blight first started killing trees, there was a lot of sort of sadness. There were headlines in the newspapers about chestnut trees dying.
Goodbye, chestnuts, grieved one 1923 article in American Forests. What was formerly a majestic, soul-inspiring landmark is now but a rotting stump. No more are they seen on Main Street. No longer do they stand in battalions in the forests. They are as few as the veterans of the Civil War and just as decrepit. And nobody really knew what to do. The blight would shrug off all the normal sprays and fungicides used to treat individual trees before, which led other people to envision more drastic solutions.
There was this idea that maybe the way to stop the blight, you might not be able to rescue trees, you might not be able to rescue forests where it was already infected, but if you could sort of quarantine them, maybe that would be a way to stop the blight. And that's sort of a classic way to deal with, what is essentially an infectious disease.
This was an attempt at preventative care. If you can't cure the blight, maybe you could stop it from spreading.
Sort of the most sad, heroic, but sort of misguided was the Pennsylvania effort. I think, is that what you're referring to?
Pennsylvania took the idea of a quarantine zone to its logical extreme and set about dividing their state in half.
And they said, okay, the eastern part of the state, Philly region, area around there, that's beyond salvation. All those chestnuts, we can't save them. But we're going to set up essentially like a fire break in the middle of the state. And everything west.
Pennsylvania decided to inspect everything west of that line, all of western Pennsylvania, inch by inch, cutting out anything diseased, in the hopes of blocking the blight from spreading westward. But it didn't work.
Now you're talking about a tree disease that may first appear as a few tiny little orange specks 70 feet above the ground. And the guys who are tramping through the forest looking for the fungus, they're surely transporting the spores on their shoes, on their axes, on their backpacks.
Wow. So this seems like a pretty overwhelming epidemic.
Right.
But were any of the trees naturally resistant?
That was my thought too. And when I asked Susan, she said that politicians and scientists eventually came to the conclusion that the only way to salvage any value from chestnut trees was to cut them down before they got the blight.
They just started chopping down the trees everywhere.
Many believe that this practice may have erased whatever natural genetic resistance existed in chestnuts.
So it's probable that there is some innate resistance in chestnuts, but we actually never got a chance to discover that because so many of the trees either died by the blight or were chopped down by people trying to staunch the blight.
In the end, we couldn't stop it. The blight won. In just 40 years, it killed 3 to 4 billion chestnut trees. Here's Wendy Cass again, botanist at Shenandoah.
I think we've mainly learned not to take the forest for granted, that the stable state of things around you is the way it will always be. they were surrounded by these enormous trees, and everything seemed stable and wonderful. And then in a matter of, for Shenandoah, 10 years, every chestnut tree in the park was dead or dying. And so
Today, only small stumps remain, occasionally sending up new shoots just to have them get knocked back once again by the blight.
So there are still chestnuts trying to grow, but they're always killed after a few years before they can grow to maturity or reproduce.
Yeah, exactly, which means that the American chestnut is functionally extinct. It's been erased from the landscape and, with each passing year, from our nation's cultural memory. The story of American chestnut and the legacy of chestnut blight, these are the stakes in our story. This is why people like Diana are worried about whitebark pine.
They fear the worst because the worst has happened before.
And in a very direct way, chestnuts also influenced the fate of Glacier's trees. The same people that tried to stop chestnut blight were placed in charge of the fight against blister rust.
So we know how it got here, and we know what can happen. What did we do about it?
Before we get down to business today, Peri, I have something for you to try. You can do a little sampling.
Treats?
Sort of. Pour you a little bit of this.
Great. All right. It smells very vegetal.
Oh, okay. How does it taste?
Very sweet.
Very sweet, yeah. Because it's a concentrate.
It tastes kind of like grape juice, but more mild, less acidic.
So what you're drinking is Ribena. It's a currant juice from the United Kingdom, and it's actually a super popular beverage over there. But you've probably never heard of it, and that's because of blister rust. So this juice, Ribena, is made from currants. The name, of course, comes from ribes, which is what scientists call currant plants. And these are really important to our story because they are the alternate host for the white pine blister rust.
Okay, I remember Diana talking about that.
Yeah. You remember she says that white pine blister rust is a fungus, and it uses currants as part of its life cycle. So it'll grow part of the year on the currants, and then when it's ready, it moves over and infests the whitebark pines. In 1911, the federal government banned the sale, cultivation, and transport of black currant. And this ban was in place for over 50 years. It wasn't until 1966 that the federal ban was repealed.
Wow.
And to this day, in 3 states, New Hampshire, West Virginia, and North Carolina, it's still illegal to grow your own currants.
So this is probably why I have not had currant juice before.
Exactly.
And so the thinking was, if we didn't have currants, we wouldn't be able to spread blister rust.
Yeah, blister rust needs currants to continue its life cycle. It can't just grow on the trees. It needs to spend part of its life on the bushes and part of its life on a pine.
So they figured ban currants and we're rid of blister rust.
Yeah, and that seemed to make sense at the time. But there were also a ton of wild currants in the United States.
Uh-oh.
This was not really a thing in Europe. Most currants there were cultivated, but you go out hiking in Glacier National Park, you'll see currant bushes all over the place.
Yep.
So even with the ban on cultivated currants, whitebark pines were not safe. There were all sorts of wild sources for this white pine blister rust.
So what did they try to do about it?
Well, to save America's white pines, the Blister Rust Control, or BRC program, was created. And from 1939 to 1965, the program operated here in Glacier National Park. And their goal was to save whitebark pine and western white pine by eradicating currants entirely.
They tried to completely remove a native plant from the ecosystem.
Yeah, it sounds pretty crazy in retrospect, but there is a certain logic behind it. It basically became clear that currants and white pines couldn't coexist. You had to pick one or the other. And white pines are so important here that people wanted to choose them and eliminate the currants.
I see. And so what did they try to do?
Well, they hired these crews of young men that would go out in the park and try to just remove all of the currants that were near white pines. They would do it manually, chopping them or pulling them, or by spraying herbicides onto these bushes. In total, they removed 4,630,900 ribes or currant plants just from Glacier National Park.
4 million plants is so many plants.
It's pretty hard to even comprehend or picture how many plants that is. It was a huge undertaking. And we can learn more about it because one of our own, Ranger Doug Follett, actually joined one of these crews in 1942. Doug is a local legend here. Now in his 90s, he spent over 50 summers as a ranger. But his first job in the park was on one of these blister rust crews.
Well, I was 16, I think. I was part of a blister rust crew. And the blister rust is the white pine disease. And the government agencies, Forest Service, Park Service, to my knowledge, they all had anti-blister rust programs. And blister rust is a spore disease that goes from the white pine tree and matures. It is blown onto the ribes bushes, which are wild currant and gooseberry bushes, and there it ripens and blows back and kills the white pines. And so in the beginning, the programs were to pull that intermediate part of the equation, pull out the gooseberry bushes, and that's what I did.
So Doug calls them gooseberries there. That's another name for ribes or currant plants. And the work he's describing, this is really tough backbreaking work.
Oh God, we didn't think anything about it. I look back now and I think, how did I do it? I can't pull carrots out of a wet garden now.
Oh man, Doug is the best. But how did this all work?
Well, to make sure that they got every single plant out of there, they would set up these grids with string.
And we threw string balls about 30 feet apart, and two guys worked between the string balls. And the mountains were covered with that very, very fine butcher shop string that all the grocers and the butchers used in those days. A very fine string that disintegrated, but temporarily all the animals were running around wrapped in grocery store string because the mountainsides were covered with these string lines.
Ribes plants could either be pulled by hand or sprayed with herbicides. The herbicides that the blister rust control program used were 2,4,5-T and 2,4-D. When you mix these chemicals together in equal proportion, you get the famous chemical Agent Orange.
Wow, that's wild.
Yeah, but their methods changed over time. In 1944, Doug turned 18 and joined the Air Force. By the time he got back to his blister rust control work, Glacier's ribes eradication program was mostly given up on in favor of directly applying fungicides onto trees.
So they were trying to directly kill the blister rust fungus?
Yeah, they came up with these really interesting techniques for applying it. I'll let Doug describe that again.
And at that time, the muscle-bound jocks from the university, building up for the football season, were now carrying 5-gallon cans of poison on their backs and squirting that poison with a little hatchet hose right into the white pine trees, trying to save them.
Did I hear that right?
Yeah, they were actually cutting into the trees with little hatchets and then injecting poison, fungicide, into the trees. There were also aerial fungicide programs where helicopters would drop these chemicals out onto whitebark forests in the park. In Glacier in 1965 alone, which was the last year of the blister rust control program, 124,000 white pines were sprayed using the fungicide phytoactin L440.
Okay, that's a huge effort. And so did it work?
Not exactly. Kate Kendall, the bear biologist we spoke with in the last episode, also studied the BRC program. And she said the main thing it accomplished was putting some men through college. In 2001, when she studied it, almost 88% of the park's whitebark pines had either been killed or infected by white pine blister rust.
So what were they doing wrong?
Well, for one, these fungicides they were spraying had basically no effect. They didn't really kill the blister rust. But there were also problems with the ribes eradication. It was easy enough to find and remove the first 80% or so of these currant bushes. You only need a few ribes plants to make it through this process to keep spreading that disease. But one of the biggest issues was that it turned out ribes were not the only hosts of the white pine blister rust. People eventually realized that paintbrush and lousewort plants were actually spreading white pine blister rust as well.
Paintbrush is one of our most common wildflowers. I mean, If I picture a high elevation meadow, like one that would have some whitebark pine in it, it probably has paintbrush all over the place.
Yeah. So even if you wanted to get rid of it, you probably couldn't. But people also started to think maybe it's not a good idea to try to remove all of these pieces from this ecosystem. What other effects might that have if we have that level of intervention? So as the blister rust control program wound down and blister rust continued to ravage the park's whitebark, western white, and limber pines, a different approach was badly needed.
Listening to these stories of people cutting down all the remaining chestnuts or trying to pull every ribes plant in Glacier, the dramatic irony is really strong. We know now that those efforts were never going to work. But while it may be easy to dismiss these projects based on how they turned out, you have to admire how much these people cared, that they would go to these lengths just to save a tree. And nearly 80 years later, Doug Follett is still writing poems about the trees of Glacier. Today, people are working just as hard, though they have the advantage of some extra decades of science and technology. I'd like to think, then, that we're better off, but we also don't know what the future holds. Will our grandchildren look back and think we were just as naive? So we just stepped off the trail into a little kind of clearing where there are a ton of subalpine fir, the kind of Christmas tree looking ones, and then there are a whole variety of whitebark too. A lot of them are dead. There's a few bushy looking live ones and some kind of in between, half alive, half dead, with some red blister rust flags on them. We're pretty close to a popular trail. We're just stepped off the trail, so you can hear people hiking by on the trail, and they probably don't even know that there's whitebark here. So we hiked all the way up here to core a tree.
I'd like to core one of these living trees that looks pretty healthy. Take a look at its life, basically, because when you take a core out of a tree, every ring is a year that tree has survived on the landscape. And that little ring, each one of those rings, will tell you how it responded to that year. And so it's really like pulling all these pages of a book out of a tree and being able to read its autobiography. And so I would like to take a look at that really big tree over there that looks really good. It's been around for a long time. It's seen a lot of stuff. And so I think it'll be really interesting to take a peek inside that tree.
Coring a tree means boring into the center of the tree and pulling out a thin piece, shaped like a dowel. It's an ideal way to learn about the tree because you get lots of information from a core, but it doesn't hurt the tree.
I can't tell if it has blister rust from here. It might. There's some dead branches. But overall, it looks really good. So let's take a look at this one.
The tool Diana uses to core the tree is basically a long, hollow screw that she twists into the tree using a T-shaped handle on one end.
And kind of the trick is you want to get it perfectly aimed into this tiny little spot in the tree called the pith that's probably a few millimeters wide, and you want to hit that.
Easy.
Yeah. I'm remarkably good at doing it, but today when somebody's watching, of course, I'll be way off, but we'll see.
That clicking you're hearing, that's the sound the core makes each time Diana turns it 180 degrees.
Because people have probably seen a cross-section of a tree, looked at the stump, and
right.
So what you're aiming for is that center.
That little dark spot in the
center.
middle. Yeah. And you don't have to have it for every kind of research you do. But if you want to know the true age of the tree and what is experienced its whole life, you really do want to get all the way into that point. Then we just stick this little thing in here we call a spoon all the way down the core center and flip it over, and that breaks the core off inside, and then hopefully the core comes out. And it did. Okay, let's see what we've got here.
Wow. So
Isn't that cool?
So you can see the rings going, so they start out kind of horizontal, and then as you get towards the center of the tree, it kind of curves around it, and you can see that's where the heart of the tree would be?
Right. So
wow,
I just
that's
missed
amazing.
the heart by a few millimeters. So
Yeah.
it would have been right here. And then these are those that are wrapping around it. So that's the center or the heart of the tree.
It's really beautiful.
It is.
Wow.
So this one has really tiny rings. It's been slow growing its whole life. Even when it was young, it was very slow growing.
So we're looking at a couple hundred years probably of growth?
Oh yeah, easy.
So like the first knuckle on my first fingers, maybe 30 years. And so to go 4, 5, 6, 7, so that's 250 years maybe?
Yeah.
Wow.
Yeah. The beetles like the fast-growing whitebark pine.
Oh.
Invariably, when we cored trees that the beetles killed and compared them to the surviving trees, the survivors were slow-growing whitebarks.
Huh.
And they also, we think, are more tolerant to drought. Because if you're slow-growing, you have less demand for water. And so you have some resistance to beetles, and you can probably survive in a warmer, drier climate.
It's like
So
the
that's
tortoise
cool.
and the hare.
Yes.
Don't overextend yourself.
And it's genetic. They can pass it on to their offspring.
And so I want to keep looking at the core.
Yeah.
So if we start, like, is this the dust bowl? Like, we probably wouldn't know.
Yeah. And boy, I've looked at some trees with dust bowl signatures. You look like, my God, how did you survive that?
Yeah.
You can see the struggle going on in that tree. And then you look at this and it's like, you've had a very boring life, haven't you? You know, you just kind of plug along, you know, but you're alive, and these guys aren't. So yeah.
I spent a lot of time looking at that little core of wood, all the little lines, each marking a year of survival. What Diana sees when she examines a tree and what she shared with me is the life lived in those lines. The good years and bad, and the hardships it's overcome. Drought years, avalanches, wildfires. People that walk by might notice the dead trees, but they wouldn't get to read the tree's story this way. This ecological education I'm getting is a double-edged sword. The more I learn about these trees, the more I'm starting to love and admire them. But it's also painful to understand what we're losing.
And I took an art class, and it was Identity in America, and I had to pick an identity and then express myself with my art. And that's when I named myself a coroner rather than an ecologist, and knew that I had a job shift. And that day nailed me to the wall. And I'm actually getting emotional right now. I'm having a very hard time with it. And I don't even know if I want to do science anymore. And that's my passion. Because why? You get into ecology because you love life. And you want to know more about what makes it tick and how it works. And because you find the intricacies and everything just so magical. And anymore, it's hard to go to work because what I see is all the things I love falling apart around me. I study symbiosis and I see them being pulled apart. You know, an ecologist is going to see a lot more than just a regular person walking around in the forest. You're going to see a lot of things that nobody else notices, and it's traumatic.
Like, what is the worst case scenario? Like, how bad could things get?
Personally, I think we will have a lot of environmental destruction, massive extinction, and societal collapse. I think we have a real ethical and moral dilemma with how we treat life around us. I think we have an obligation to support everything that's living on this planet, and not just for our own benefit. Everything has its own right to exist.
So one of the questions that we're exploring is whether people can have a positive impact on the world around us, on the natural world.
I think we can, but will we? I guess is the right question, because so far we're not doing a very good job.
Even if we can help save this species, we've lost a lot and we will lose a lot. And I think a lot of conservation looks back at, we've broken things, how do we fix them? How do we put them back to how they used to be? And maybe that's not a helpful frame anymore, because we can't put them back.
Next time on Headwaters, we meet the people trying to save whitebark pine. And they can be found climbing trees.
You get a really unique perspective being in the top of them, looking at these like big, beautiful cones. Nothing like a whitebark pine cone.
Reaching all the way out to the ends of their branches to place cages over their cones, keeping them away from all the animals that rely on their seeds.
Headwaters is a production of Glacier National Park with support from our partner, the Glacier National Park Conservancy. Glacier is the traditional lands of several Native American tribes, including the Amskapi-Piikani, Kootenai, Salish, and Kalispel people. Headwaters was created by Daniel Lombardi. Andrew Smith, Peri Sassnet, and Michael Feist produced, edited, and hosted the show. Ben Cosgrove wrote and performed our music, and Claire Emery let us use her woodcut piece titled Wind Poem for this season's cover art. Special thanks this episode to Bill Hayden, Annie Gustafson, Rebecca Lawrence, Diana Six, Wendy Cass, Susan Frankel, Glenn Taylor, Stacy Clark, Tara Carolyn, Doug Follett, everyone with Glacier's Native Plant Program, the Whitebark Pine Ecosystem Foundation, and so many others. And if you liked this episode, share it with someone else who loves Glacier.
This is like for the end.
This is in it, yeah. You saying that's going to be in it.
The Glacier Conservancy is the official fundraising partner of Glacier National Park. To learn more, visit glacier.org.
I think that's the best one you've done yet.
Okay. Do I need to go one more time?
I think we're good.
Yeah, I think
Okay.
that's good.